This is page number 52, using addition with probability. I want to talk to you quickly about using addition with probability. Essentially, sometimes you have situations where you've got two things you're looking for, and so you have to add up the possibilities if what you're looking for is or. It has to be either this or that. So for instance, on number 1, a sum of 6. If you look at, and by the way, these are number cubes that are rolled, and you've got all the possible outcomes. I do want to point out that the sample space is in 2 rolls, and they have kind of done it in order where you decide, like, the first dice you roll is vertical, second dice you roll is horizontal, represents the second toss. So which of these are a sum of 6? Let's see. 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4 is 6, and 1 plus 5 is 6. So all of those, that's 1, 2, 3, 4, 5. There are 5 possibilities where the sum is 6. 5 out of 36. Okay? 5 out of 36. And then where the sum is 10. So let's see, 6 and 4, 5 and 5, 4 and 6. Those are the ones where the sum is 10. And there are 3. So that would be 3 out of 36. The fact that they said or means that you're going to add those. Okay, so essentially you're just going 5 out of 36 plus 3 out of 36. That is 8 out of 36. And 8 out of 36 simplifies to, let's see, 4 into 8 goes twice. 4 into 36 goes 9. So the probability is 2 out of 9. Furthermore, it's asking, are they mutually exclusive? Meaning, are any reds blues or are any blues red? And the answer is no, they're not, which means these are mutually exclusive characteristics. Okay, so let's go to the next one. The next question asks a sum of 3 or a sum of 7. So a sum of 3 is what I'm going to do right now, and that would be 2 and 1 is a sum of 3, 1 and 2 is a sum of 3, and that's all. There are 2 out of 36. Okay, a sum of 7. Well, let's see. Here they are. 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. Okay, so that's 1, 2, 3, 4, 5, 6 out of 36. So when you take a look at those, that would be 6, 7, 8 out of 36, which is also 2 out of 9. And if you take a look at that, is there any overlap at all? And the answer is no. So far, so good. So let's go to the next one. The next question asks a sum of 9. All right, so it adds up to give you 9. That would be right here. 6 and 3, 5 and 4, 4 and 5, 3 and 6. So that's 4 out of 36. Or a 5. And so we're looking for things that, oh no, notice it doesn't say or something, a sum of 5. It just says it has a 5. So that would be all of these vertical on the 5s here have a 5, right? And all of these have a 5 going across. You will notice in this case that there is overlap. There are some blues that are that magenta color. So even though, if you look, you've got in the purpley pink color, magenta, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 out of 36. What you have to do minus the probability of sum of 9 and 5. So you're looking to see how many overlapped here. The probability of 9 and it has a 5, that would be 1, 2. So what you would have to do is subtract out 2 out of 36. Okay, so if you've got event A and event B, okay, in order to figure out the probability of event A, well, here, let me get it. Probability of event A or event B, you have to figure out the probability of event A, add it to the probability of event B, but you have to subtract out any that happen in both A and B. You have to subtract out one time the overlap that A and B both accounted for. Okay, so that's the formula. I'm going to tell you that I don't use the formula, that way I don't have to subtract. And so I'm going to show you quickly an easier way to kind of look at this rather than that formula, which is just a little bit heinous. All right, so the first thing I'm going to do is get a highlighter, and I'm going to do a product of 20. Okay, that means two numbers multiplied to give me 20, and 1 times 20 wouldn't be in this sample space. 2 times 10 is not in the sample space. 3 doesn't go. 4 times 5 does, so here and here, and 5 times 4 does, and then you're back to the beginning. Okay, or a 6. Okay, meaning it just has a 6. So all of these here have 6s. All of these here have 6s in them. So what I'm looking at is, or trying to see, is number one, is there any overlap? And if there is no overlap, and there is no overlap, then these are considered to be mutually exclusive. Okay, product of 20 or 6, here's all I do. If it's got a highlight or a box around it, I just go through and count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It is 13 out of 36. Okay, and I'm done. I don't have to add, subtract, multiply, divide. I'm just counting basically. 13 out of 36. And let me go back here too. Since there was overlap here, that's called inclusive on number 3. Okay, so you see how 4 is just a lot easier if you don't try to calculate them separately, and then just make sure you don't double count as you're going through these. Okay, so a sum that is less than 10. Less than 10, and I'm going to make that this color. 2, these all add up to less than 10. That'd be 3, 4, 5, 6, 7, 8. Those are all less than 10. 4, 5, 6, 7, 8, 9. Those are all less than 10. And in fact, up to there, those are all less than 10. Okay. 5 and 5, 4 and 5, that's less than 10. That's 9. All of these are less than 10. So that's the first part. And the second part is a sum greater than 8. So this diagonal right there is where they're equal to 8. So I'm going to, these are 9. These all add to 10. These all add to 11. Since you're seeing or in between the two of those, then what it's asking you is basically, if it's highlighted, you count it. And if you look, every single box, all 36 are highlighted. So that means that this is 36 out of 36 or 1. Okay, if the sum is less than 10 or the sum is greater than 8, that's everything in the whole sample space. So moving on. Let's do the next one, a sum of 3 or less. So your two rows are adding up to less than 3 or less, so you can count the 3. That would be those 3. Or double ones. Alright, you will notice there was overlap. However, as long as you just do what I do, 1, 2, 3, and count the end result, what is highlighted or circled, then you're going to get the right answer. So that's going to be 3 possible ones out of 36, which is the same as 1 out of 12. And by the way, those overlapped, so they were inclusive. And these overlapped, so they were also inclusive on number 5. Number 6, a product of 5 or less, or a 6. So I'm just going to go back here, and I'm going to show you some different things, how to do product you're multiplying to get 5 or less. That would be there. That's 2, 2, 3, 4, 3, 4. The 3 times 2 is 6, so that's not it. 2 times 3 is 6. 1 times 4. 5 or less, so you can count 5 and 1. And I believe I believe that's it. Everything else is going to be larger than 5 or a 6. Alright, so what I'm going to do is put boxes around those. And again, I'm doing this not with color on this one because in all likelihood when you take the test, if you were going to do a problem like this, you're going to have a pencil and that's it. So I'm just going to show you how you could like turn your pencil kind of to the side if you wanted and shade with the side of the pencil. But I'm just putting a box for the second one and a circle for the first one. And the reason I do them separately is because I need to ask the question. I need to answer the question, excuse me. Are they mutually exclusive or are they inclusive? Now, looking at this, you'll notice that none of the boxes overlap with the circles, which means they are mutually exclusive. Okay, and now let's just count. So I'm going to go through and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So they're mutually exclusive. They represent 21 out of 36 boxes. Let's see, 3 goes into 21 7 times, 3 goes into 36 12 times. And so that is your answer to number 7. All right, next one asks for an even number. And notice it doesn't say that it has a sum of an even number. It just says somewhere, I guess, there's an even number. Okay, so if you look at that, anything in a 2 column or row is going to end up having an even number, at least one. So I'm going to do even numbers or circles. And then I do the rows. Anything that has an even number. Okay, and then a sum of 7. That would be a 1 and a 6, or a 6 and a 1, a 2 and a 5, so a 2 and a 5, 2 and a 5, a 3 and a 4, or a 4 and a 3. Alright, so is there overlap? Yes, which means they are inclusive. Okay, and let's count the numbers now. Basically, out of 36, it's all but, it's all except 1, 2, 3, 4, 5, 6, 7, 8, 9, which means it's going to be 27 out of 36. I just subtracted, basically did 1 minus not this. No. Okay, so 27 out of 36 is 9 out of 12, which is the same as 3 out of 4. Alright, next one is an odd number or a product greater than 25. An odd number, so I mean it's very similar. If it has an odd number, I'm giving it a circle. And all the way down. I've done all the columns. Don't forget that there are rows that contain odd numbers as well. And so there we go. So I've circled everything except 1, 2, 3, 4, 5, 6, 7, 8, 9, or a product greater than 25. So let's look at this. 6 times 6 is greater than 25. 5 times 6 is greater than 25. Greater. 6 times 4 is not, but 5 times 5 is. And that's it. So this little box of 4 down at the bottom were the only ones that had a product greater than 4. So if you notice, we said there were 27 that I had already circled. Of those, only one new unique one was included when I did the product greater than 25. So instead of 27 out of 36, it's actually going to be 28 out of 36, which is the same thing as 14 out of 18, which is the same thing as 7 out of 9. And so, and by the way, there was some overlap of 3 different values. So that makes these inclusive. And the last one, a product greater than 20 or a product less than 15. Again, I'm going to go through this as if I'm just using a pen or a pencil like you would be during the test. So product greater than 20, that'd be 1, 2, 3. I'm looking at those. 6 times 4, 5 times 5, 4 times 6. Not 3 times 6, but, and actually 4 times 5 is not greater than 20. Okay, and that's all of them, or a product less than 15. And so let's see, less, all of these are less than 15. 6, 8, 10, 12, that's less than 15. 3, 6, 9, 12, that's equal to 15, so I can't count it. All right, that's 4, 8, 12, that's 16. 5, 10, that is equal to 15, and then 1 and 6, and 2 times 6 is 12. All right, so if you look at these, those are mutually exclusive because there is no overlap at all. And out of 36, it looks like I've circled or X'd all but 1, 2, 3, 4, 5, 6, 7. So 36 minus 7 would be 26, 25 out of the 36 total. And that's your answer. And so taking a look at these, just making sure that those are correct. Hold on. Number 10 was one that there was an error. And let's just double check here. 1, 2, 3, 4, 5, 6, 7. Right, and 36 minus 7 is in fact, oh, wait, hold on. I think all right, so 36 minus 7 would be, and I'm doing this because it was actually right as it was written over there. It's actually 29. I did it wrong the first time. So that's 29 out of 36. And that is incorrect on your answer key. That's just a publisher's answering key, but just be careful about that. Okay, and so those are your answers. Fix number 10 on your answer key, and let's take a look really quickly at these. These particular questions, it just took me just a second to figure out something. You get a swim team with 25 members, and if you'll notice, it's divided up. There are 8 swimmers who swim freestyle, and so if you look right here at all of these in yellow freestyle swimmers, the numbers, that's 3, 4, 5, 6, 7, 8. So there are 8 total. They're divided into different groups. Okay, and it tells you that let's see, 5 swimmers who swim the backstroke, and the 2, 4, 5 is correct, and 7 who swim the breaststroke. So it wants you to find the probability of each event that it lists below. But here's something I want to point out to you. If you look at all of these swimmers, it's just something that if you're not paying attention, you might miss this. There are, I'm just going to go through, hold on. Look at everybody here and count them. That's 3, 4, 5, 6, 7, 8, 9, 10, still 10, 14. Okay, there are 14 total who are listed, swimmers who swim the freestyle, backstroke, or breaststroke. If you look though, it's just an interesting thing. There are 25 members on the team, which means that if this is the whole team, this box represents the entire team, you've only got 14 swimmers listed. There are 11 who don't swim those 3. I'm trying to think, I don't know, 11 who do the butterfly, I guess. Who knows, but or maybe there are 11 who don't get to compete. But that's the team, and just remember there are 11 out here, so that there are 25 all day. Okay, so here's what it's asking about this group. It wants to know what is the probability if you just picked one person from the team. What's the probability that they swim freestyle? Well, that's, remember, 3, 4, 5, 6, 7, 8. So that would be 8 out of 25. Okay. What's the probability that they swim exactly 2 events? I want you to notice that freestyle is 1. Okay. Backstroke is another. And then breaststroke is this third. If you look, and it may be hard to see with this green, the very center of that, that's a kid who swims all three. Okay? The only ones that swim only two are the ones that are outside of that very middle. So here, these are the kids, these two are the kids that swim freestyle and backstroke. These two swim freestyle and breaststroke, and these two swim breaststroke and backstroke. And that one swims three, so you can't count it. So the total is 2-4 out of the total 25. Apparently I'm going in odd order here, but freestyle and backstroke. Notice that it doesn't say only freestyle and backstroke. So it's asking about kids that swim both of these overlapping. And this is the overlapping area. Remember that one in the middle does swim three, but that's not what it says. It doesn't say that they have to swim only two, just that they do swim two. So that's 3 out of 25 for that one. Then it says, and I'm going back up to number 12, technically I went in a weird order. Swims exactly 2 events. Oh, actually, hold on. 4 out of 25, we've already talked about that. I just put it in the wrong place. Swims breaststroke or backstroke. Here's breaststroke. And think about it. This is everyone who swims breaststroke. Okay? You can choose any of those people, or you can choose anyone who swims backstroke. So this is the or means it's everybody. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Still 11. Those are all the ones that swim one or the other. So that's 11 out of 25. Okay? And then does not swim the backstroke. If you think about it, these people right here, backstroke consists of 5 people, right? Well, there are 25 on the team, so how many don't swim backstroke? That would be 20 out of 25, which is 4/5. Okay? And lastly, anyone who does not swim freestyle, breaststroke, or backstroke. In other words, they're these people outside of this team right here. These don't consider any of those. And that would be a total of 11 out of 25. And that's the end.